This is question number 19, GATE 2016 Metallurgical Engineering. Creep resistance decreases due to A. Small grain size, B. Fine dispersoid size, C. Low stacking fault energy, D. High melting point. So firstly, what is creep? So creep is defined as time dependent deformation at elevated temperature and constant stress. So let's say if we have a material, we are keeping it at a temperature T and we are applying uniform stress, let's say compressive here. So let's say P is the load applied, which is generating compressive stress throughout this cylinder, and we are holding it at time T. So what will happen if you are below the yield stress also, this material after like a long time will try to deform or like relieve the stresses caused by this load. Hence, this deformation caused by a constant stress at a higher temperature is basically creep. And creeps are of two different types. One is diffusion creep and another one is dislocation creep. So what happens in diffusion creep is like diffusion of atoms takes place from one region to another. So there are three modes from where diffusion of atoms can take place. First is through bulk, second one is through grain boundaries, and third one is the surface diffusion, which we are neglecting here. So two are the major diffusion mechanisms from where the atoms or vacancy can migrate from one place to another. And second one is the dislocation creep, which occurs by moment of dislocation through lattice and causing strain in structure. So these are the two different types of creep mechanisms, and creep usually occurs above 0.7 of melting point. This is given because as we are talking here of diffusion of atoms and vacancies, so diffusion is a like temperature accelerated process. At higher temperature, diffusion will be faster. Hence, for vacancies and atoms, higher temperature is required. So if we consider higher melting point, in higher melting point, what will happen is like we will require higher temperature to cause the same creep in a material. Hence, the creep's resistance will increase if we have high melting point. And let's talk about low stacking fault energy. Let's say what happens in dislocation creep is like one dislocation is moving in certain plane, and has some hindrance here, so it cannot move here. So what it does is like it can cross slip this dislocation to some another plane and try to slide here. So using cross slip, what happens is like dislocations try to move away from any hindrance and give plastic deformation by its movement. So what happens when low stacking fault energy is there? It gives like a more stacking fault width is there. Hence, if more stacking fault width is there, it is difficult to cross slip for a dislocation. Hence, decreased mobility of dislocation. If decreased mobility of dislocation is there, creep resistance will increase, not decrease, because creep resistance is because we should hinder the path of dislocations. Hence, C is also not the option. Now coming to fine dispersoid size. So let's say we have one dispersoid here, and this complete is a matrix, and one dislocation is trying to move here. So let's say it is going like this on this slip pen, which it encountered by a dispersoid. So what it will have some hindrance in the moment. So what it will do is like it will try to like shear this, like shearing will occur like this. If you have studied this, shear will occur like this, or it will try to just go around this dispersoid. So what is happening because of this fine dispersoid is it is creating more hindrance to the dislocation moment, which is basically increasing the creep resistance. Hence, fine dispersoid size is also not an correct option. And smaller grain size. Let's consider that I have a structure like this, where these are different grains. Okay, and one is with bigger grains. Now coming to the same point, as diffusion creep occurs by diffusion of atoms and vacancies through bulk oblique grain boundaries. So here you can see the grain boundary fraction is higher Hence the diffusion at a particular temperature, if both conditions are same, like for this also temperature and stress are constant, so what will happen is like atoms and vacancies can migrate easily through this large number of grain boundaries than this, because here the grain boundary fraction is less. Hence what will happen is like this material will creep faster than this material because of diffusion is high here rather than here. Hence this will decrease the creep resistance, and which is A, because of smaller grain size and a large number of the grain boundaries fraction. Hence the correct answer is A here.